Zero friction, pure electromagnetic power. This is the future of transit. This is not science fiction. Pure magnetism unlocks a revolution in motion. A marvel of speed, flying hidden from the world. While most remain unaware, the future has already arrived. In the 60s, it was just a dream, fueled by decades of failure and redesign, pushing the limits of physics. To carve a path through Japan's unforgiving peaks demanded engineering of absolute precision. It began as a vision to connect a region, but scale brings complexity, pushing engineering to its limits. Deep beneath the Earth lies a hidden network. Tunnels stretch for hundreds of kilometers, threading through complex geology. With deep beneath these peaks, a grand feat of human engineering takes shape, breaking through granite, meter by meter.
Pressure's dropped, we hit a fault zone.
We must stabilize the wall now!
Deep inside the mountain, conditions can change in an instant. Despite advanced planning, nature remains unpredictable.
The initial forecasts were carefully planned,
We must revise the budget immediately.
but unforeseen challenges.
After years of setbacks, the work never stopped. Today, the dream takes flight. Engineered for a greater purpose. This is precision operating at the limits, redefining distance itself. Deep beneath the mountains lies a world of absolute cold. Here, superconductivity defies gravity. Work has suddenly ground to a halt. Billions of dollars are now at risk. The technology is ready. Reversing time reveals the very spin. Tokyo, 1964. A new era begins. Steel on rail has redefined our world, but physics imposes its own limits. To go faster, we must leave the tracks behind. Japan's high-speed rail operates with clockwork precision, but this triumph now faces a new challenge. Japan's iconic Tokaido corridor is operating at its friction disappears as imposter than the system can accommodate. For centuries, terrain dictated the route. Now, precision engineering carves its own path. For centuries, steel ground against steel, but physical limits demand a new approach. Magnetic levitation removes friction entirely. For centuries, rail was defined by friction. Magnetic fields change everything. This is a new paradigm. In the early 1960s, a bold journey began. To master the very laws of physics, laying foundation. It began with a simple concept, decades of relentless research. Today, the fiction becomes reality. In 1977, a breakthrough changes everything. This was just the beginning. In the late 70s, a quiet revolution began. Engineers pushed the limits of speed, an ambitious experiment in Miyazaki. Years of research led to this moment. Inside the center, the atmosphere was tense. The vehicle rises. This is the moment of levitation. Magnetic power defies gravity. Friction entirely disappears. A machine that defies gravity, riding not on rails but on magnetism. Pure, frictionless motion. After decades of testing, Japan faced its greatest barrier, To go through the Alps required rewriting. On the surface, it is a challenge of scale. But beneath lies a hidden world. Here, engineers must map. What appears solid becomes uncertain underground. To conquer these peaks, we must first understand them. Through decades of research, every fault line is mapped. Beneath these peaks lies a world shaped by eons. Here, modern engineering meets ancient geology. Deep beneath the peaks, immense stress fields become an active force, shaping the engineering itself. Deep beneath the Japanese Alps, standard designs fail. Algorithms redraw the route in real time. Deep in the Japanese Alps, conventional engineering failed. To survive these extreme pressures, we had to reinvent. Decades of planning become reality. Japan's future is carving through solid rock, an engineering feat. But approval was only the beginning. On the surface, the scale seems overwhelming, but the true challenge lies deep beneath. Massive machines battle ancient geology. The Yamanashi Line is a laboratory at full scale, the birthplace of a transport revolution. This is not a passenger railway. It is a full-scale laboratory, where every aspect is refined. Deep beneath the mountains, a massive cycle begins. Every meter is carved and secured through precision engineering. Deep within the Japanese Alps, precision blasting fractures the solid rock, advancing meter by meter. Deep beneath the Japanese Alps, a pilot tunnel leads the way. Engineers study real-time data. Deep within the Japanese Alps, this is the system's forward sensing line, revealing what lies further along the route.
Alignment confirmed within 2 millimeters. Proceed with the next segment.
Deep beneath the Japanese Alps, a new ultra-precise tunnel takes shape. Here, micro-adjustments guarantee stability. Deep within these tunnels lies a breakthrough in engineering. Thousands of coils work in harmony, generating precise magnetic fields. These coils perform multiple critical functions, providing propulsion to move the train forward, guidance to keep it aligned on the track. Unlike conventional rail systems, propulsion forces are generated externally by the track, rather than by machinery inside. The guideway itself generating powerful forces. Electromagnetic forces propel the vehicle. Every individual coil is precisely synchronized, continuously supplied with power, and constantly monitored in real time to ensure seamless operation. This system delivers variable frequency current. It flows directly into the track infrastructure. This enables smooth acceleration control. System online, monitoring position with absolute precision. Stability and safety are fully guaranteed. Delivered in 1995, the first prototype appeared completely stripped down, giving the distinct impression that key components. This is motion without mechanics. No wheels touch these rails, only pure magnetic force. Gliding into the future. A sleek train rests above a precision-engineered guideway. Magnetic systems activate, and the vehicle rises, gliding through the tunnel with zero physical contact. Decades of research come down to this. In 1997, theory became reality. Stable, full-scale the magnetic system activates, lifting the 20-ton vehicle. A precise 10-centimeter gap is maintained. Begin levitation sequence. All systems are clear. Velocity pushing past 500 kilometers per hour. This is the future of high-speed travel.
All systems are green. We have just passed 600 kilometers per hour.
A new world record. A new mega project is unfolding, carving through ancient rock. True scale lies within the earth. A new mega project is unfolding, carving through ancient rock. True scale lies within the earth. To build massive structures in a crowded city, these unseen concrete walls form a fortress, resisting immense pressure so construction can proceed safely. Tower cranes lower components into the abyss. Inside this vast cavern, weeks of work compress into seconds. Piece by piece, a 4,000-ton giant is born, ready to carve its path. Tower cranes lower components into the abyss. Inside this vast cavern, a giant is born. Countless smaller machines work together, operating with millimeter precision. Deep beneath the mountain, maintenance is critical. Specialists enter a high-pressure chamber. This visualization shows the confined space. With checks complete, the Colossus moves again. A pilot tunnel leads the way, mapping the unseen rock, preparing the main machine. Every step begins with understanding. Deep beneath the Alps, data guides the way. But ahead lies the untouched unknown. The mountain still holds countless secrets. Deep beneath the Alps, standard drills fail. Real-time data reveals hidden hazards. Engineers must adapt to survive. Instant changes reshape the tunnel. Nature dictates the final route. New survey results reveal conditions far different than anticipated. The tunnel boring machine slows to a stop. Engineers analyze interactive models. Conditions become too complex for the massive boring machine. In the control room, the strategy is revised. The giant machine is withdrawn from the face. At times, water inflow reached 10,000 liters per minute. Here, circular engineering turns excavated rock into an essential resource. The mountain itself becomes the very structure that supports the railway. Here, circular engineering turns excavated rock into an essential resource. The mountain itself becomes the very structure that supports the railway. Circular engineering turns rock into a resource. The mountain becomes the railway structure. The mountain becomes the railway structure. Beneath these untouched peaks lies a hidden giant. This shaft plunges 400 meters down. It connects to a vast underground, a critical link hidden from the world above. Japan is building the future of rail. 60 sites working in perfect harmony. A massive engineering ecosystem. The world's largest coordinated infrastructure. Japan is building a massive system, a network of sites across the country. They are advancing through solid rock. Every update is monitored live, a unified system for the future. Deep within Japan's rugged mountains lies a colossal engineering marvel, carved directly from solid rock. A modern station, meticulously sculpted. Deep beneath the mountains of Japan, a vast transportation hub is being born, to rival the world's largest city stations, a masterpiece of underground engineering. Cavernous spaces stretch into the darkness, yet there are no support columns. Thousands of anchors lock it into the bedrock, the mountain itself a feat of pure rock engineering.